Okay, so let's talk about section views. In this presentation, I'm really going to focus on examples because conceptually, I think section views are kind of easy to understand. They're a way that we can show the interior detail of an object through orthographic projection or orthographic views. But the number of types of section views can be a little bit overwhelming, and some of the variations need to be specifically spelled out. So I think it's best right now if we just kind of focus on the different examples. I would also like to say that the chapter in your textbook that covers section views is an excellent resource, and you should definitely use it when you're doing your section view assignments. All right, so with that being said, let's get into the types of section views. So section views, as I said, are used to show interior details more clearly. As opposed to showing them with hidden lines, we want to show them with visible lines. A cutting point line is a line that's used to show where the object is actually being cut in the orthographic projection or in the orthographic views. That's called a cutting point line. Section lines are the lines that are used to show where the solid material has been cut by the cutting point line. Section views, obviously, may be used to replace standard views, standard orthographic views, your top, front, right side, left, bottom, back view, all those views. We generally want to omit hidden lines in section views. There are some exceptions to this rule, but generally speaking, 99% of the time, and hint, hint, in our homework assignments that you're going to be working on, you want to omit the hidden lines in the section views. Now, let me be very clear. When we talk about omitting hidden lines in the section view, we're talking only about the view that is the section view. Not the other views, not the views that have the cutting point line, only the section view. And finally, I'm going to talk about some conventional practices. These are basically, you might call them cheats, so that you can simplify your object, do some kind of conventional practice to show the object more clearly. And by doing this, we're going to kind of not follow the true orthographic projection. Okay? Maybe a little bit fuzzy and hazy, but when I'll show you the examples, I'll make sure I explain it well. All right. So first of all, section view. This is a full section view. Okay? This is an example of a full section view, and we can see on the left-hand side here the object. And the blue plane here, what looks like a piece of glass, the blue plane is the cutting plane, all right? And that is what we're going to imagine is cutting the object in two, all right? So in this case, it's slicing through the middle of the object, and it's going to separate the object into a left half and a right half, okay? So this is how we make a section view, or in this case, a full section view. Full section means that the cutting point line is cutting through the entirety of the object from top to bottom in this case. Okay. So the cutting plane is going to be shown as our cutting plane line when we get to the object, which will be in the next view here. We see the drawing of what we just showed you. Okay, so I want you to first look at the front view here, the circular view. You can see here where the cutting plane has been replaced with a cutting plane line, okay? The cutting plane line has two arrows on either end, and the arrows indicate the direction of sight for the section view. Now, what does the direction of sight mean? It basically means where we view the object in order to see the section view. So the arrows are pointing, in this case, to the left, so that means our eye is going to be somewhere out here, and we're going to be looking to the left to see the cut section. And that's where our section view is right there. So one rule of thumb that you want to remember is the arrows always point away from where our section view is going to be. Arrows away from where our section view. Okay. Now, so the right side section is shown here, right, as it should be, and you can see all the detail here. On the left side, we have the mirror image, basically, but this would be the left side view of the object, and here it's shown with the normal hidden lines. And I think this is really to visualize or to be painfully clear how little information we get from an object that's shown, from a view that's shown with hidden lines, okay? These hidden lines really don't help us to understand what's going on inside the object. There's hidden lines here. There's a lot of different levels and different layers and all that goodness that really doesn't help us to understand what the object looks like, or certainly what's going on inside the object. On the other hand, the right side section view here, we can clearly see that we have 4 of these rather complex multi-diameter holes on the top and the bottom. We have a hole going through the center that opens out to a larger diameter on the back surface. So we get a lot more information from the section view. Okay. So as I said, the full section shows the object cut in half. The cutting point line can be omitted in some cases if it's understood to be through the center. So this is kind of one of those conventional practices. Technically speaking, we do not have to show a cutting point line here if there's only one section view, right? So if we have multiple section views, we're going to have multiple cutting points, and so we need to show them all. But if we only have one section, it's a full section, we can omit this cutting point line. And it's replacing the standard view, in this case, the right side view. All right. Now, moving on to the cutting point line. There are 2 variations for the cutting point line. We can have a variation that's shown on the left, which is just a solid dotted or dash lines with uniformly spaced dashes, uniformly length dashes here. Or we can have the cutting point line shown on the right-hand side, which is a long dash and 2 short dashes repeating. Typically, we're going to use, and in AutoCAD right now, we're using the one on the right. Right. I want you to notice that the cutting point line in both cases is a thick line, so it's going to be the same line weight as a visible line. Okay. You know, all the spacing here you don't have to worry about because it's going to take care of all that. So that's it. We put the cutting point line has its own layer, cutting point layer, and that's going to be a thick layer. All right, section line patterns. So you can see there's a lot of different section line patterns. And actually architects use this too. So you'll see some architectural patterns here for concrete and sand and earth and all that good stuff. There's some engineering patterns here for different materials, magnesium, white metal, steel, cast or malleable iron, cork, all that good stuff. Now, this is an old chart, all right? This is not the current standard for engineering drawings, okay? So we are not going to use this. In fact, the current standard is only the number 1 pattern in the top left. We also call this pattern the ANSI 31 pattern, ANSI 31. ANSI stands for American National Standards Institute. So this is the ANSI 31 pattern. That is the only one that's approved for use right now with engineering drawings. So all these other ones, forget about them. Okay, we're only using the top one. All right, so let's look at cutting point sections. You'll see I've hidden part of this screen here so that you can just focus on the one drawing in particular. So we can put the cutting point lines in different views, and then therefore our section views will show up in different views. So here we have a cutting point line in the top view. And so our section view is in the front view, or is the front view, the section view of the front view. Here, the arrows, again, are pointed away from where our section view is. So arrows away, all right? And that's going to create that view. And you can see the diagram of what this is, what this looks like 3-dimensionally, Okay, what this is intended to show you. The cutting plane is shown here, cutting the object in two, and we're looking at the cut half on the back side. Okay. If we look at the middle object, we can see here the cutting plane line is now being shown in the bottom, or what we might call the front view here. And the top view is our section. Okay. So again, here on the left, we have our cutting plane line in the top view, which results in a section view in the front view. Here we have our cutting plane line in the front view, arrows pointing away. So our section view is, in this case, the top view. So it really doesn't matter. Wherever you put your cutting plane line, that's going to determine where your section view is. Or the other way we can look at it, where you want or need your section view, that's going to determine where your cutting plane line is. Okay. You will notice here that this is not an error. The section lines are omitted right here, and the reason why is because if you look closely, you can see right in there. There is a gap in the object. There's a split in that, and you can see it down here in the front view. There's a split there. So the cutting plane line here is cutting through air. It's not cutting through solid material. Hence, there is no section lines there. In the same way, we don't have section lines here because the cutting plane line is cutting through air. Okay. Let's look at the last example here. Now, this is a little bit more complicated. In this case, we want to have a section view of two orientations or two views of the object. So we want a front view full section, and we want a right side view full section. Okay. So in this case, the top view actually has two cutting plane lines, AA and BB. Right. AA generates section view AA here. BB generates section view BB here. Now notice the BB is the right side view, and of course it could be rotated and shown up here as well, but I think it's clear to see that this is also perfectly acceptable. All right. Notice also that we must label these cutting plane lines because we have more than one. All right, so here we don't need to label AA or AA here. It wouldn't be wrong if we did, but we don't have to. Here, we do need to label them because there are two different cutting plane lines, two different section views. Okay. All right, hidden lines and section views. As I mentioned, omit hidden lines and section views. Okay. The reason why we're making the section view is to clearly show interior details, and if we add hidden lines back into that, then that's going to basically confuse the issue again. So we don't want to do that. There are some very limited cases where hidden lines can be or should be included in section views. These are a couple of cases where that is true. Okay, these two examples right here. Maybe not even this one here. I'm kind of having a hard time with that, but it's possible that this would be a good use of that. I will say again that none of the drawings that you're going to be working on in class should have hidden lines in your section view. Okay? And once again, as I said before, this is your section view. Right? Not this. This is not your section view. This is the view with the cutting plane line. Again, this is your section view, not this. This is your cutting plane line. So if I show hidden lines in this view, yeah, absolutely. You have to. Boom, they're there. Hidden lines in this view, probably not. All right. Section view, not section view. All right. We also, when we're showing our section lines, right, and remember the section lines are where we cut through solid material, we want to be aware of how the section lines are lined up with visible edges of the object. And we want to avoid where the section lines line up with the visible edges of the object, because it just makes it more difficult to comprehend, to understand the geometry of the object. So this is not good. Right, where it's running parallel. Also, we don't want it running perpendicular. Okay, that's also not good. So something like this on the far left is certainly the best option in this case. Okay, you can change the hatch angle in AutoCAD to fix that. All right, we're not dimensioning yet, but just for future reference, when you're dimensioning, we do not want to put the dimension inside the hatched or the section lined area. It says that this is okay. I would again say, yeah, it's kind of not okay. You kind of probably don't want to do that. All right. This definitely is a no-no. This is the most advisable practice. Pull the dimension out of the section levels. Okay. But like I said, we're not doing dimensioning yet, so we kind of don't have to worry about that. All right, let's look at some other variations on section lines. There's a lot, or sections. There's a lot of different types of section views. So we already looked at full sections, and all the examples prior to this slide were full section views. Now we'll look at what's called a half section. And a half section, if you look in the three-dimensional view, the half section, we're removing basically, in actuality, a quarter of the object. But the cutting point line, if you look over here on the right-hand side, the cutting point line removes half of the object that we're going to section. Okay, and so it ends up creating a view, a section view here, where we have, in this case, the left half of the section view is sectioned, right? Because that's where the cutting point line cuts. Right? That gets removed. And the right half of the section view is just the normal view, right? Because there's no cutting going on here, no cutting point line. So that's normal view. Okay. This is used when we have symmetrical objects and we want to show the outside and the inside of the object. Okay. I will make special note, there is no visible line right here. This line right here is a center line. That's it. Now, in fact, you will see textbooks make this mistake. Other drawings, other people will make this mistake as well. This is not to be a visible line, because in reality, there is no visible line there, right? So it's, in this case, going to be a center line. Right? All right, this type of section view is called a broken out section. And this section view does not get a cutting point line because basically it's like we break part of the object. And notice what separates the unsectioned half from the sectioned half is a break line right there. There's our break line. It's a visible line, so a dark, thick, continuous line that's kind of wavy and random, right? And then we show the sectioned half of it. So here we're showing this little pilot hole, and then the unsectioned half out here. So that's called a broken out section. You're not doing a broken out section in your assignment. Revolve section. A revolve section is where we want to show the cross section of an object, but not make a separate view. Right? So what we do is we slice into our object. So you can see here the cutting point line. We slice into our object, and then we turn the cutting point line so it shows, and we put the section view right down on top of the object. And so this is the finished view. So it's kind of like in one view, we're putting the section view and the other view. So it's kind of like in one view, there's actually two views. That might be too confusing for you, but it's how this cross section is placed right into that view. Now, you are doing a revolve section in one of your drawings. I think it's drawing number 4, drawing number 5. Okay, so you are doing a revolve section in there. Okay. And then here's some other examples of revolve sections. So in this example, we're trying to show, and in the top view, you can see where the cutting point line is. We're trying to show where the cut is being made. And we want to show the cross section for this, basically this cross brace, right? You can see the cross member here kind of looks like a cross. So we want to show that detail. So we're going to cut in there, right? And then we're going to put the cross section back right in the middle of that view. Okay. Now, if this is a little bit too confusing, Right? If there's too many lines going on here, you are allowed to break around that. So you see how we have our break line there to kind of isolate this. So either this view is acceptable or this view is acceptable for showing the revolve section. All right, let's go to remove section. Remove section, this is another one that you're doing in your assignment, and actually you're doing it in the assignment with the revolve section. So you're doing a removed and a revolve section in one drawing. And remove section is basically a revolve section where we remove the section view out of the part. Right? So a revolve section would have these little things, section CC, section BB, section AA, placed up here in the object, right? But maybe that's too much. Maybe there's too much going on in there. Maybe we want to pull these out so that we can clearly see. Maybe we want to dimension these features more clearly, so we don't want them in the object right there like a revolve section has. So we remove them. And the cool thing is we can put them wherever we want to on a drawing. We can even put them on a separate drawing sheet that says, hey, these remove sections are on a separate sheet. But it's a super handy dandy way of showing a cross-sectional detail without getting bogged down in all the other stuff. So one of the things with the revolve section, and certainly in this case with the remove section as well, is notice we are only looking at the cross-section. We're not including any lines behind the object, right? Anything like that. All we're looking at is the infinitely thin cross-section that creates section AA, section BB, and section CC. Okay. All right, an offset section. An offset section looks a lot like a full section. Okay. The difference is in a feature where we need to use an offset section, the different features do not line up. So in this case, in this example right here, if we look at the top view, I think it's a little bit more clear. Notice that this hole and this slot and this hole and this hole do not line up. So there's no way that one straight cutting plane can cut through all these different features that we want to expose with the section view. So how do we create a section view exposing or cutting through each one of these features? Well, we basically make turns in our cutting plane line. So if you can imagine, the cutting plane line starts here and it's going to travel through here, and then it's going to turn. It's going to turn 90 degrees and go up here, and then it's going to go straight again through that slot, and then it's going to stop and it's going to turn here, and it's going to go through this complicated hole and stop there, and then turn and exit through this last hole, and then we go and we put the arrow on the end. Right? So that's going to generate this section view. Right? A couple things with this. All right. Most importantly, notice that wherever we made our turn, right there, right here, and right here, these do not show up in our offset section view. Right there. There's no line there. Right here, boom, there's no line there. And right here, there is no line there. Okay, so in fact, this section view alone is misleading because it shows us, or it implies, that all of these features are lined up in one line. But we see clearly that that is not the case in our top view where our cutting plane line is. So therefore, it's an offset section. Okay. So do not show the bends in the cutting plane. Secondly, and this is just a little note, the addition of the hidden line in here, I would say is wrong. Right? This is an example of where I don't think you need the hidden line through here. I don't think it helps or explains anything extra. Okay. So that's an offset section, and you are doing an offset section in your drawings. Here's another example of an offset section. This one is one object, right? You see that the what we might call the front view here. Let's call this the front view of the object. Right? And you can see there's three cutting plane lines. We have section AA, cutting plane line AA, section BB, and section CC. and this creates section A here. And you can see this has one bend in it, boom, right there. Section BB, right? And this has, we make a turn here, we go make another turn, and then we come out. And then CC, now we come down through this horizontal hole, cut through there, make a turn, cut through that, and come down here in section CC. So we can line these up. So in essence, we have 3 right side views: section A, right side section, section BB, right side section, section CC, right side section view. Right. Notice in each case the direction of the arrows, where arrows point away from the section view. So that's our direction of set. Right. And again, we do need to label these because we have 3 section views, so we must label them A, B, and CC. All right. Do not section thin ribs or webs. All right. Why? Well, because it's confusing. All right. So in this example, let's look at cutting plane line AA. So cutting plane line AA cuts through the thin half of the rib. This is, or web. This web here. This little web right here. It's cutting through the thin section here. If we, and we're cutting through solid material there. So according to the rules, we should add a section line in that area here. But you can see in this example here, this is misleading. This kind of implies that this whole area is solid here, when in reality, it's just a thin rib or a thin web. So the correct conventional practice is to omit the section lines in the thin web area. Okay. Now, what's a little bit confusing is it does depend on how you cut the web or rib. Okay, so look at section BB. We're cutting through section BB is cutting through the web this way. We would still section that or show section lines in that area. Okay. So there's section A, and that's really what you want to focus on here. Oh, and by the way, I should add, you do have a thin rib in one of your section view drawing segments. Right, our line section, another conventional practice is to when we are slicing through features that are not parallel to the principal plane of projection. Remember, the principal plane of projection in this view, which was called the front view, and the right side view, is a vertical line going through here. The cutting plane line is now not parallel to the principal plane of projection here. So how do we handle that in our section view? Well, we draw our section view as if all of these features were rotated in or parallel to the point of projection, and then we project them through. Right. Now this can be confusing for some people, but I think the next slide will show it. Will show what we do this. Let's look at this. Actually, let's look at the next slide here. This one right here. This is a good one. Yeah, let's go back. There we go. All right, so same thing here. This looks a little bit more complicated, but it's not. All I want you to focus on is the ribs right here. So we have 3 ribs, right? And the cutting plane line is really going straight down. We have a straight vertical cutting plane line. And this rib clearly is not in the cutting plane, right? It's not being cut. And so you would think that this rib would be shown like this, right? So here we have the foreshortened view of the rib, right? And here we're cutting through the rib. So, hey, we slice through the rib, but no, this is not how we do it, right? Because this is misleading. Not only that, this is terrible to draw. This would be very difficult to draw. So instead, we want to pretend as if the rib is rotated into the plane, and then we project it so that it's symmetrical. Also, notice that we don't section the thin ribs. Right? So this is correct, and this is much easier to understand than this. Right? Also much easier to draw. Let's go back one more, and let's go back one more. Well, this is also more examples of a line section. I put a lot of line section examples in this presentation because I think it's helpful to see more examples. So here again, Cutting point line is going at an angle. So what do? We rotate this feature over here and draw it as if it was in that position right there. Okay. Also, it's a thin rib, so we don't section it. Right. Here, we do the same thing. We don't draw it like this. We imagine that this is rotated over here, and then we project it and draw it like this so that we get a symmetrical object. Note though, and I have seen it. Some students do this. They will actually draw this feature over here in the view. You don't actually draw it there. You only draw the section view like that. Okay. I think I skipped one more, so let's go back here. Yeah, this one shows a series of holes, so it's a little bit more difficult to kind of see what's going on. But we do the same thing for holes, not just ribs and other features. So in this case, the cutting point line AA takes a turn here, so we want to draw this hole, which is a counterbore with a hole, as if it was shown right here and project it through. This is the true projection, right? True projection meaning we project exactly what we see, and that is wrong. Right? So this is what we want to draw. All right. So I think that's it. I think I kind of went backwards on the last ones here. So the last thing, I put this out there because it's covered in your chapter. We're not actually doing anything with this in this assignment. These are just conventional breaks. So if you have an object that's too long to draw and you want to break it so that you can draw it on a smaller sheet of paper, these are how we do conventional breaks. Don't worry about it. We're not covering this in the assignment, so we don't have to. You don't have to worry about that. All right, so those are the prime examples, the different types of section views. Please use this as an example guide when you're doing your drawings. Also, the textbook is very, very good. Okay, so later on, I'll be dropping in some more AutoCAD demonstrations of section views. In the meantime, I'll talk to you in the next video.